So our last section in Chapter 7 is 7.6. We've done stuff similar to this before, okay, solving trig equations graphically. Now we're going to solve them analytically, which means using algebra. So we're going to look for equations that factor. That's always the quickest way. If it doesn't factor, we're going to have to look for quadratic, okay, using quadratic formula. The other thing to keep in mind is whenever you have a quadratic equation, it has to have all the same variable. So if you had something like y squared plus 3x plus 4 equals 0, it's not an equation we can solve because it has two variables. Same idea comes up with trig. We have to have all the same trig function, okay, in the problem. So when we're working with the equations we're going to solve, factoring is a good idea. I just mentioned that. Rewriting it in terms of one trig function, and using the quadratic formula. Okay, so we're going to start off with ones that are pretty straightforward, pretty easy, and then we'll build up to ones where you have to do more and more steps. Now, some of the problems in the homework, they're going to be even easier than the first one I start with. Okay? First one that I start with, you're going to have to factor this somehow. I think the first 4 problems in the homework, they start you the step before this, a step easier. They factor it for you already. Okay, so I'm starting you off with pretty much the ones that you always have to factor yourself. All right, so first I'm going to look at the directions. It says find all solutions between 0 and 2 pi. So we are not putting plus 2 pi k on our answers. Okay, we're finding specific solutions. Is that a quadratic equation in the form that we want? Why not? Yeah, we've got 2 different trig functions. It's like having 2 different variables. Okay? So we have to rewrite one of them. The hint is generally to rewrite the one that is squared. So I want to fill something in for cosine squared. Now, an identity that's going to pop up a lot is this. It's a Pythagorean identity. And can somebody tell me what cosine squared would be using my Pythagorean identity to substitute? Well, Quinn?
Is it 1 over sine squared?
Not quite.
No, 1 minus sine squared.
It's 1 minus sine squared. All right, so now let's distribute out the 2 and rewrite it in order, combining like terms from highest exponent to lowest. So I'm going to start with this. What's 2 times negative sine squared? Negative 2 sine squared x plus sine x. And what's 2 times 1? 2 plus 1, 3. Now that's a quadratic equation, and it's all using the same, basically the same function. The only thing about factoring that is there's something here that's a little weird. Okay, factoring this would be like factoring this. What's a little strange about factoring this? Something you usually try to avoid. The what? Yeah, whenever we factor, if you want to follow those rules that you know from Algebra 1 with factoring, you need the x squared term to be positive. So what can I easily do in either equation just to make that a positive 2? Yeah, just change the sign of everything by multiplying it by negative 1. So we have positive 2 sine squared x minus sine x minus 3. And then when you multiply 0 by negative 1, it stays 0. All right, now I want to see if I can factor that. Okay, if I can't, I'll use quadratic formula, but I think that's going to factor. What would be my first term in the parenthesis on the left? Yep. 2 sine x, and my first term in the parenthesis on the right. Sine of x. So if you multiply them, that's 2 sine squared. Negative middle, negative constant. What does that mean about my signs? Plus and minus, and the order does matter that we do it in. I'm going to do it as minus plus. If you don't, well, you would see you might have to switch something in a little bit. And now I need two numbers that multiply to give me 3. 3 and 1, and this matters where we put them. So where should I put the 3? In the first one? And the 1 in the second. Okay, let's check it. 2 sine squared. We get 2 sine times 1. That's 2. Minus 3. 2 minus 3. There's my negative 1. Okay, so we just factored that equation. If it helps, you can rewrite it temporarily as 2x squared minus x minus 3 and factor that, and then change everything, change all your x's back to sine x's. If visually it just looks confusing. But any questions up to that step? And now we solve this just like it was 2x minus 3 and x plus 1. What do we do with each factor? Set them each equal to 0. So either 2x minus 3 equals 0, or sine x plus 1 equals 0. Right, so on this one, okay, what would sine x equal? Okay. It would equal 3/2. And my last step to get x by itself would be to do what on each side of this equation? Yep, take the inverse sine. And what's going to be the inverse sine of 3/2? How come? Right, you can't take the inverse sine of 1.5. Right. So for this part, there's no solution. Doesn't mean the other part is no solution, but this part is. So now we'll look at the other part. Okay. Sine of x would equal negative 1. And now we have to take the inverse sine of negative 1. Can you do that? Yes. Negative 1 is between negative 1 and 1. Okay. What's the inverse sine of negative 1? Yeah. Either an exact answer in using pi or in degrees. But yeah, we want an exact answer. Think about the graph of sine. Where does the graph of sine hit negative 1 at what angle? Yeah. At 90, it hits positive 1. At 180, it's back at 0. Nope, 360, it's back at 0.
Yeah, it's that.
270. All right. If you want to think of it on a unit circle, find on the unit circle where the y value, because that's sine, where is the y negative 1? When do you go down 1? Well, if you go down 1, that's 270 degrees. Or if you did it in radians, what's 270 in radians? 3 pi over 2. Okay, I'm going to do radians a lot of the time because that one's harder. If you can do radians, degrees numerically, it's easier in your head. And that's it. You don't have to worry about a second solution using the ASTC diagram because that answer is not in a quadrant. It's on an axis. Okay, if you get an answer in a quadrant, then we would have to say, okay, where else is sine equal to a negative? We have our reference angle and go through that. Okay, but not in this one. And that's it. That's your only answer. Okay? And it's within the range they said to be. It's between 0 and 6.28. Okay? 3 pi over 2 is about 4.7. So if we get an answer that's not between what they said, then we don't have to write that either. But that is between what they said. Any questions on that one? Now, this one's a little different. They don't tell you where to find answers between, like 0 and 2 pi. You have to figure out how big one period is. So what's the period of sine to an even power? We had a chart, I think it was probably earlier in chapter 7 or the end of chapter 6. Anybody remember the formula for sine to an even power? And while people are looking that one up, does anybody remember the formula, period of cosine? That's just basic cosine. What's the period of that? Yeah. Yep, period of cosine is 2 pi. And what's the period of sine squared? Yeah. Just pi. If there was a 2 here in front of the x, that would change something. But sine to an even power, the period is pi. What's the least common multiple of those two numbers? 2 pi. So now we have to look for answers that are within a window of 2 pi units. The easiest way to do that is what we did in the last problem. 0 to 2 pi. Okay. You could do negative pi to pi. That's 2 pi. You could do 2 pi to 4 pi. But this is the easiest. And notice you don't include both endpoints. You include 0, you do not include 2 pi. All right, so now we know where we're looking for our answers. We can start to solve the problem. Okay, is this a quadratic in the right form? No, a couple things wrong with it. What's one thing we have to do first that it's actually an extra step we didn't have to do in the last problem?
Well, we have to set one side to 0.
We have to get one side to 0. So let's bring everything. You know what? Actually, I was thinking in my head, why don't we bring everything to the left and then we can keep the squared term positive, because that's what we want when we factor. But remember, this squared term isn't even going to stay here, right? We're going to substitute in for it in a little bit. So chances are the squared term is going to become negative anyway. So what I'm going to do is I'm going to bring everything to the right. Okay, that's how I'm going to do it. So let's get 0 on the left. As I'm kind of thinking ahead a couple steps to when I do a substitution, and it's going to turn the sine squared back to a positive for me without having to divide by -1. If you don't want to do that, that's fine. Just divide by -1 is simple. So I'm going to have -2 sine squared x plus cosine x plus 1. And now we've got it equal to 0. So is that a quadratic the way we can solve it?
No.
No, still wrong. What do I have to do now?
You have to make both the same trig function.
I got to have both the same trig function. So which one should I substitute for?
The sine squared.
Let's substitute for sine squared. Not the 2, or not the -2, just the sine squared. Everything else is going to stay. What is sine squared? Yep. Yeah. And now watch what's going to happen when you distribute to your squared term. What's negative times negative? So your squared term is going to become positive 2 cosine squared. So I just avoid having to divide by -1. So I've got that part. Okay, I'm going to come back to the other distributive in a second. Plus, what's going to come next? Cosine x. And what's my last number? Right, -2 plus 1 is -1. Okay, now we've got a quadratic that we can solve. Okay. Any question on that one? So sometimes when I'm trying to factor it, I look at it like this for a second. and I ask myself, can you factor this? What do you think? Anybody see a way to factor that? Jeff, if I was going to factor, what would I have to try first after I put my parentheses?
You'd have to put the x's, and then it would be like 2x and 1x.
Okay. And then what would your signs have to be?
Plus and minus.
Yeah, so up to this point, you don't have any choices. The only thing you can multiply to get 2x is 2x and x. Your signs have to be a minus and a plus. I did have a choice with that, and I did it like that. And what about two numbers that multiply to give you 1?
Having plus 1 and then minus 1.
So the only choice you have is a 1 and a 1. So the only thing I could have done different here is switch the signs. And if this doesn't work and switching the signs doesn't work, then there's no way to factor it. But does that work? How come?
Yeah.
It doesn't work because it equals, what equals 1? So does anybody have a thought here we can confirm or deny if that works? So the factoring, this is the algebra part. So this part we want to make sure we're confident on. Francisco, what do you think? How do you check if that works? What do you do?
Factor it out.
It's already factored.
All right, when you
2 times plus minus
solve
1.
it,
How do you solve it? How do you
distribute it.
distribute it?
There we go. 2 times 1.
So what's 2x times x?
2x.
What's 2x times 1?
2x.
2x, take away 1x.
X.
And what, negative 1 times
Works.
1? It works. So now, that's not really my problem, it's similar. What does the one above it factor as?
2 cosine.
2 cosine, no, not squared. 2 cosine x minus 1. And what about the other one? Not a 2.
Cosine x.
We're just replacing these two things with cosine x. So cosine x plus 1. Okay. So now, what do we do with each factor? Can somebody tell me when you set the one on the left equal to 0, what will cosine x equal to after you move all the numbers? 1/2. And let's do the other one. What will cosine x equal there? -1. Okay, how do you solve both of those? Look, Tom, you solve that. Yeah, take the inverse cosine. So let's start with inverse cosine of 1/2. So inverse cosine, 60 degrees, or in radians, that would be pi/3. But there's another answer. Okay? That's cosine equal to a positive. What other quadrant is cosine equal to a positive? The fourth quadrant. So we can think in degrees temporarily. Your reference angle is 60. What do you do with your reference angle to get an answer in the fourth quadrant? Yeah, which is how much? 300. What's 300 in radians? Well, how much is pi over 3?
60.
What do you multiply 60 by to make it 300? Okay, any questions on that? All right, you guys tell me how to do the second one.
Inverse cosine, both sides of becomes x equals the inverse cosine of -1, in which x would equal sine of 2. Right?
Yeah.
X would equal
All right, let's double check. Inverse cosine pi. Okay, and all those answers are between 0 and 2 pi. Okay, so that's what they wanted. Okay, questions on that one? All right, so this part, you don't have to write this part down because this is what we've done before. So this is when you're finding all solutions. Okay, today we're not finding all solutions. We're finding a specific solution, and that's it. You're not putting plus the period times n. Okay, so no plus 2 pi k or 2 pi n today. But I just want you to remember, there really is infinite numbers of solutions here. But we're just focusing between 0 and 2 pi in this problem. Okay. So is that a quadratic? Okay, Pacey? No, not written that way. Any suggestions what I do first here?
I would turn tangent into cosine.
Okay, and what would tangent be if you do that? Yes. Okay, that's a good first step. Okay, what would we do next? Yeah. Yep, times both sides by cosine. And we're going to get this. And now, this equation is basically where I started you in the last problem. So now, from here, just do what we did in the last problem. Okay, so what would I do next? You can subtract sine. If we do it that way, eventually the cosine squared is going to turn negative, and we're going to have to fix it. But it's fine to do it that way. Still not exactly the way we want. What do we have to substitute for?
You have to put 1 minus sine in for cosine squared.
Can you say what you want to plug in right there again?
1 minus sine squared.
Yes. So 1 minus sine squared. And now when we distribute and write it out, we will have a quadratic. Okay, the way we want. Can somebody tell me what my quadratic would be?
Negative 3 sine squared of x minus sine x plus 3.
Plus 3. Now, if we were going to factor this, I would want the squared term positive. But if you look at it carefully, this doesn't factor. Okay, you can't factor this one. So, how else can I solve a quadratic? Yeah, use the quadratic formula. We just have to remember, when we get the result from that, what we actually solved for. Are we solving for x? Sine x. Okay, when you're done, you're going to get your quadratic formula. You'll get a number. That number is equal to that part right there. It's not the answer. It's the sign of the answer. Right, so we'll have a step at the end to get rid of sine. So do it just like it's quadratic without trigonometry. What's A? B? Great. Okay, so fill in to the formula you guys gave me earlier. So negative b plus or minus the square root of b squared. So 4ac all over 2a, which is negative 6. Okay, right away, I have minus a minus, so I'm just going to turn it into a plus. So we're pretty much going to be done this in one step. What's 4 times 3? Times 3 again, and then plus 1. 37. Okay, so we get 2 answers, and thank you. And what are those? What is that number equal to? Is that x? That's sine x. So, what is my last step? Yeah, and that's my answers. How many answers could I get from doing this? How many? Oh, anybody think they know how many answers I could get at most? 4. When you do inverse sine, you have the plus version, okay? And then you'll get, there's 2 quadrants where sine could equal a positive number, and then the minus version, 2 answers where sine could equal a negative. Let's look at this carefully. What's the square root of 37? Roughly, just give me an idea. A little what? It's a little bigger than 6. And if you take a number a little bigger than 6 and add 1 to it, what do you get? A number a little bigger than 7. If you take a number a little bigger than 7 and divide it by 6, what do you get for an answer? A little bit bigger than 1, or negative 1 in this case. So if you want to, if it's confusing, you're like, what is he talking about? Just do it out and watch what happens. Square root of 37 plus 1 divided by negative 6. It's negative 1.18. Can you take the inverse sine of negative 1.18? No. So you don't have to worry about the plus. That just got rid of half our answers. Now, the minus will work. Okay? So that we need to do out. Okay, and we've done a lot in radians. Let's we can do one in degrees just to practice. So the inverse sine of 1 minus square root of 37. And you know what I'm going to do? I'm going to put parentheses around the numerator. The calculator might do it fine, but with order of operations, I'm not sure. Okay, so do 1 minus the square root of 37, divide by negative 6. Take the inverse sine, and we get an answer of 57.90. Okay, so that's, if you did this numerator out, would the top be a positive or a negative? 1 minus the square root of 37. That's a negative. And in the bottom is a negative. So what's a negative divided by a negative? Positive. So this whole thing right here is a positive number. What other quadrant is sine positive in besides quadrant 1? Second. So what do you do with that number to get an answer in the second quadrant? 180 minus it. So your other answer is 122.1. I think the book did radians. So in radians, you get 1.01 and 2.13. That's what they get. All right, so if you look at the book, our answers are different because I did degrees. Okay. So, any questions on that one? It's not overly hard, but there's a lot of simple things to remember, like is it 180 minus, 180 plus, things like that. This one's very similar to the other ones. Does anybody want to see another one of the same type? This would be a quadratic equation, I think. Okay, that one's a little different. So it says 3 tangent to the 4th x equals 1 plus secant squared x. And they want us to just find answers between negative pi over 2 and pi over 2. Okay, if we want to solve this, any thoughts about what I should do first for any equation I want to solve that has this kind of, it's almost something, but a couple things we got to do.
The first thing I do is change secant
You want to change something with the secant? Okay, I think that's a good idea. And there is an identity for that. It's not the sine squared plus cosine squared equals 1. It's the one right below it in that list. Does anybody remember the identity for secant squared?
It's like 1.
Yes. 1 plus tangent squared. What I circled is 1 plus tangent squared. All right, so now I'm going to do a couple things at once. I have some like terms I can combine, and I should get this equation equal to 0. So let's do both at once. So we've got 3 tangent to the 4th. What would be my middle term? It would be negative tangent squared. And what would be my constant? Minus 2, okay, because we're combining, we're moving at the same time. If it's confusing, combine first and then move separate. But any questions on this? Now, this actually isn't too bad. Okay, this is a quadratic equation. It's even more general. Okay, anytime that the first exponent is double the second one, and the last thing here is just a number, that's a quadratic type equation. If you used quadratic formula, what would you be solving for? You'd be solving for tangent squared. So you'd have to, at the end, take a square root of both sides, and then you would have tangent equals, and then you'd have to do an inverse tangent. But I don't even think we need to use quadratic formula. This factors. What would have to be my first two terms in each set of parentheses? You don't have any choice. Okay, if it's confusing, look at it like this. Pretend that you're trying to factor that.
3x squared,
Well, 3 tangent squared. Yep,
and then 1 tangent.
and then a 1 tangent squared. And now my signs are minus and minus. So what do they have to be when I factor? I heard plus minus. I'll try them in that order. If it doesn't work, I need to switch them. And two numbers that multiply to give me 2. 2 and 1. And which one should I put in the first? 1. Let's check it. So we get 3 tangent squared times tangent squared. It's 3 tangent to the 4th. We're going to get a 3. Just check the numbers in front. 3 times negative 2 is negative 6. What's 1 times 1? So doing it in that order, I get a negative 5. That's not what I want. So what should I try here? Yeah, let's try switching with the 1 and the 2. Let's put that there and that there. Okay, now I get, what's 3 times negative 1? And what's 2 times 1? And negative 3 plus 2, there's my negative 1 tangent squared, and 2 times negative 1 is negative 2. So we factored it. If you were factoring the one above, it would be 3x squared plus 2, x squared minus 1. Now what do you do with each factor? Set them equal to 0. So in the first one, what will tangent squared x equal? You have to move the 2 and 3. Negative 2 over 3. Or, what will tangent squared equal in this one? 1. Okay. On both of these equations, what would be the next step? Nope, not inverse tangent. There's another function we have to do before that. We have to take the square root of both sides. So we take the square root of both sides, we get that. Zach, any thoughts? Does anyone have any thoughts about that? Yeah, good luck trying to solve that. How come? It's imaginary. You're trying to take the square root of a negative number, so you can stop. If it wasn't imaginary, then I would be taking the inverse tangent of it. But since it's imaginary, I'm not even going to bother. You can't take the square root of a negative. Let's look at the other side. Okay. What would be my first step here? Square root. So what would tangent x equal? The square root of 1, which is kind of plus or minus 1. If we forget that, then we're going to lose half of our answers. So the square root of 1 is plus 1 or minus 1. So now we really have two problems here. I need to solve this one, and I need to solve that one. Okay, so what do we do on both of those? Yeah, do the inverse tangent. So I'm going to do second inverse tangent of 1. Let's do it in degrees, because you're going to get a nice answer. And then in radians, what's 45? If you know 90, it's half of that. Pi over 2 is 90. Pi over 4. The reason I did it in degrees first is because if the decimal for pi over 4 came up on the screen, I don't think you would recognize it. So that's why I do it in degrees first, see if you get a nice answer, and then that's easier to change to radians. And then negative 1 is negative 45. And those are your two answers. Yes, you could write your answer like this instead. If you didn't want to write like I did separate, that's fine. questions on that one? Right, so every problem I give you algebraically, there has to be some kind of trick to make it work. Okay, it's not just random numbers I picked. Something special is going to happen every time. And the same thing here. Something nice is going to happen. We're not going to use quadratic on this. We're going to use factor by grouping. How do you know when to use factor by grouping if they didn't tell you? Look at this problem is very different than the other 4 that we've done. So.
If there's like 4 terms that have something else.
Yeah, you've got 1, 2, 3, 4 terms. That's not a quadratic type equation if you have 4 terms. So you definitely can't use a quadratic formula on this. But factor by grouping might work. So factor by grouping, look at what the first 2 have in common, look at what the last 2 have in common, and factor it out. Okay? So what do the first 2 that I underlined have in common? Cosine x. If you factor that out of the first, what are you left with? 2 cotangent. If you factor it out of the second, I heard positive 3 or negative 3, yeah. So now with factor by grouping, the goal is to see this again somewhere. Hopefully that pops up again in the next part. What can I factor out of the next 2 terms? I can factor out a 3. Sometimes you also have to factor out a negative to make it work. This time I think we're okay. Let's just factor out the plus 3 and see what happens. Hey, what do you get if you factor a 3 out of the... Actually, is that going to work with a plus 3? All right, what would you get if you factor out a plus 3? Yeah, that's going to work. If the sign is off, you just switch it. And then, what did you say? 3 times what is negative 9? Negative 3. Yeah, so I confused myself. So that worked perfect. Now, what does this term and that term both have in common? So factor that out. That has to happen with factor by grouping, and that's why I picked these exact numbers. If you factor it out of the first, what's left? Cosine. And if you factor it out of the second, what's left there? Just a plus 3. And that's it. Now you factored it. Something times something equals 0. So what do we do with each of these factors? 7 equal to 0. What would cotangent x equal? I'm going to move the 3 and then move the 2. 3 over 2. And now, what function cancels out cotangent? No, those are reciprocals. Inverse cotangent. Do we have an inverse cotangent button on here? Well, this isn't a sine or cosine, so rules are a little different. We don't have to pay attention to that as much here. But we will in the other part, which I'll get to in a second. But yes, do we have an inverse cotangent button? No. But what function do we have on the calculator that's related to cotangent? We have the tangent. So if you know the cotangent equals something, then you know the tangent too. If the cotangent is 3/2, what's the tangent? The tangent is 2/3. They're reciprocals. And now we can do that. How would you get x by itself here? Inverse tangent, which you have a button for. It's, this is not going to come out to a nice answer. So if I type it in, Inverse tangent of 2/3 is 33.69 degrees. The original problem didn't say to do either one. So I'm going to do it in degrees. Now, you got to be careful, because where else is tangent equal to a positive? What quadrant? Which one? Third quadrant. So what do you do to get an answer in the third quadrant? 180 plus the reference angle, 213.69. I'm going to come back to that in a second. Let's look at this one. Cosine x here would equal -3. Can you do that? No. If you set cosine x plus 3 equal to 0, that's a no solution. So we don't have to worry about anything with that. The only thing I want to be careful of is, what did the directions say to do? In one period. So I want to make sure that I am within one period. What's the period? These are all to the first power. What's the period of cotangent? Yep, pi. How about cosine? 2 pi. Cosine again. Cotangent again. What's the LCM of all those numbers in blue? 2 pi or 360. So as long as I list answers between 0 and 360, I'm okay. I'm fine. Any questions on that one? All right, so I think I have 2 left. 3. That one's the same as this one. Sine 2x equals sine x. Sine 2x equals cosine x. This one and this one are really the same thing. Just slightly different, but almost the same thing. Let's do this one. What's really wrong with this one? We haven't seen this before, but we did look at it yesterday. Yeah. Yeah, we haven't had any problems that had 2's in front of the x's. Every problem we solved, it was always a 1 in front of the x. Okay? So the first thing we have to do is get rid of that 2 in front of the x. And then hopefully when we do that, it's going to turn into something that we've done earlier today. Yep. 2 sine x cosine x equals sine x. And now what would we do from here? Think about your strategy. Anytime you want to solve an equation like the ones we've been doing today, get it equal to 0. So how could I get it equal to 0? Sure, we could subtract sine x. Okay, so I have it equal to 0. Is it a quadratic equation? No, definitely not. It's not going to be able to be turned into one. So it's not going to be something we use quadratic formula on. What can I do on the left-hand side, though? It's something I can do. Yeah. Do you want to subtract, or I thought you said factor at first? Did you say factor? Oh, I thought you said factor. I guess I was just thinking what I wanted you to say.
Oh.
Yeah, that's a good idea. So we'll factor on the left-hand side. These are not like terms, so we can't subtract them. This is like 2xy minus x. If it was 2x minus x, if we didn't have this, then we could combine like terms. But we don't have like terms here. But we can factor. Okay, what do both terms have in common? Okay, if we factor that out of the first term, what are you left with? 2 cosine x And what about the second term? Minus 1. And that's really the hard part. So now we've written it as something times something equals 0. So what do I do with each factor? Set them equal to 0. So sine x equals 0. Or cosine x equals 1/2. And these are both going to lead to solutions, possibly multiple solutions. There's nothing here bigger than 1 or -1, which we do have to pay attention to now because we're dealing with sines and cosines. Where is the sine of x equal to 0? And we're doing it in radians, between 0 and 2 pi. Think on the unit circle. If you were to draw that out, what angles would have a y value of 0? 0. And 180. 0 and pi. Now this one, a little harder to think of unless you have it memorized, but it is a nice answer. If we take the inverse cosine of 1/2, does anybody know what that comes out to? Yeah, it comes out to 60. Inverse cosine of 1/2 is 60, or pi over 3. Now, you've got to remember, we're looking for where cosine is positive. I think we already did this. Where else is cosine positive? Yeah, 5 pi over 3. Right? Yeah, so I think we already did this. And all those answers are between 0 and 2 pi. If you get a repeat, you don't have to write the same answer twice. Okay. Any questions on that one? It's a little different because it had the double angle, but it still worked out exactly the same. Factor it, set it equal to 0. Or if you couldn't factor it, well, in this case, I'd have to give you one you could factor. Okay. That's really exactly the same problem. It's very, very similar. This one, let's just see if we could set it up. It looks like it could be a quadratic, because I see something squared. What do I have to substitute for and definitely get rid of right away? Actually, this might not even be, might be actually much simpler than the standard quadratic. It's an easy quadratic, I think.
You would have to put 1 minus 2 sine squared.
Yeah, I'm seeing something squared. Why don't we put else, if we can substitute cosine 2x with something that looks like this, that might help us, because then maybe we can combine like terms. And what did you say cosine 2x was? 1 minus 2 sine squared x. Minus 2 sine squared x. So because that happened, this problem actually is going to work out very easy. What's minus 2 sine squared x? Minus 2 sine squared x. 1 minus 4 sine squared x. And because you don't have another sine term, you just get x by itself. Okay, you would have to subtract 1, divide by -4, take a square root, and then do an inverse sine. You're not going to have to do any factoring or quadratic formula, because there's only one variable in the whole problem. So you just finish that up. Any questions on at least getting to this step? Okay, so that's the end of chapter 7. Okay, so that's solving quadratic equations, or different types of trig equations. Our last chapter we're going to do that really has any new trig in it is chapter 8. So once we finish chapter 8, that finishes up the trig bulk part of the class. Okay? And then chapters 9, 10, and 11 is kind of some miscellaneous topics and some new things you've never done on the calculator. Okay. Okay, so on the homework, problems, let's see, on page 423. Problems 1 through 10 are easier than anything I did in class. They are problems that they basically start you off at, let me just show you one. They start you off at this step right here. They start you off at factored. But then after number 10, those are like the ones we did in class. 11, 12, 13, 14, 16, and 19. Okay, so 1 through 10, those should be very, very fast. Okay, so we'll take a look at that tomorrow. Remember, my extra help is tomorrow. Progress reports close Friday, so if there's anything you need to make up, it's got to be in by Friday.